Hi, I'm Jeff. Yes, I'm a composter. What I would like to do is make sure that we are getting to this point, which is a reference facility that serves this community, that is a client of mine. I am the composting director for Green Mountain Technologies. We're a 12-person company in Bainbridge Island, Washington. We are actually one of the top three, probably even the top compost facility designers in the US. It doesn't take much to do that, but it takes experience. So we have it. Our client is Timber Creek Recycling, and they are led and owned by Mike Mercoitio. And Mike, come on up. You're going to have to be here too because you're up next. So why did you guys get started?
Well, my background is cattle and farming, so my family has been farming here since 1912, the Treasure Valley, and it's kind of evolved, as the city's kind of grown in around us. We've kind of innovated and kind of followed into different practices of, innovative farming practices to, sustainability measures of like how you feed cattle better, and that kind of morphed us into, composting. So one of the things we did was we were taking different feedstocks and reincorporating them into our farm ground. And then it kind of evolved into doing it into a kind of a commercial level. So what we started doing is kind of as the city kind of encroached on our farm ground, we decided to kind of evolve into a commercial compost facility. So we hired our team up. We hired Caleb Lakey and Jeff Gage, who is our consultant, to kind of help us accomplish that. So you want to kind of join us here?
Yeah, so my name's Caleb Blakey. I joined the company a little over a year ago. I'm an engineer, so Mike had me join his team to help with operations. As the company has grown, we're going to show you today as we went from kind of a farm field application to commercial application. The operation became more complex and more regulated. So my role in the company over operations is to help try and smooth out the operations and then interface with our regulatory partners at the Department of Environmental Quality and the health departments here locally. So I'll talk more about that.
All right. So want to make sure you guys know what we're trying to get across. It seems simple. This is the thing that practitioners that you're going to find, farmers that you've run into traps of not really thinking clearly about their composting and getting back to the basics. And to get a concise composting operation, you have to do the following that are all up there. I could read it to you, but we're going to go through all this. It's really simple. I'm not going to go through it except for the folks who are listening in. Build close to your primary feedstock. Get paid for something that comes inbound because it's now yours and you own it. Mix and moisten it as you receive it. No stockpiles. Actually, of anything is what we've been learning. That includes the wood waste, even if you want to keep it dry. You want to turn weekly in the initial stages, and you're blowing air at least once every 10 minutes in that first 2 to 3 week period. Hopefully 4 weeks if you can get through with that. After 3 to 4 weeks, you can double up your piles to get rid of all that small pile stuff that you no longer need if you did the first stages right. Then you go send it to storage, try to protect it from the weather, allow it to cure in its own time, and be ready for the market condition, which is screening and getting it back into use. So we're going to go through some of the process we went through here, the examples and situations that will deal both with windrowing and with
there you go.
Oh, weird. Both with windrowing and with aerated systems.
So this is where we kind of got our start is manure composting with our own family farm. And we bought this Scarab, and we decided to buy a bigger machine than what we needed because we kind of seen the future where this was going, and none of our other fellow dairymen were composting. They were just hauling out in their fields, and then we kind of see the shift in the manure management plans that they needed to kind of start doing this. So we bought this machine. This is a portable machine. You kind of see the tires there on the other side, so that kind of folds down, and it goes from farm to farm to farm. And so we were able to do our own stuff. And then we kind of switched to other stuff. Big piles, we tried doing mass, is what our goal was with this machine, but it's not always the best. Here. So when we were helping the different dairymen out, we want to try and make sure their feedstock was really close to where we're going to make the product. because it's really wet, it's really heavy. So those efficiency curves go up the further, or they go down the further you go away from your feedstock area. So you try and get it as close as you possibly can. Because when compost gets down and condenses, it can help with your efficiencies on the other side. But you want to have, when you first do it, you want to have it as close as you can. It's not working here.
I know.
Let's just do this here. Okay. So one of the important things is your feedstock and how you mix it. You're looking for that kind of that 15% roughly of your oxygen level. So how you do that is you incorporate different feedstocks. So you want to have like your manure and your carbon source, whether that's straw or mulch, whatever you're using for that carbon source. And you want to try and put it into a windrow to where your turner can go through it. So when you're sizing it, you're trying to maximize that space. That's what we're trying to do here. We're trying to get as much material as we can with the type of turner you have that'll go in your small space. So having different feedstocks mixed properly is in.
And Mike, your client is doing that, right?
Right. Yeah. Thank you.
As they go.
Right. And we're informing them how to do that. We're telling them the proper ratios to what we can do on the backside because we're helping them market it. So we're like, hey, you got to add a little more of this, or we're kind of train them as we go. So that's really important. Now, every site is different. So like the one you see on the left, it takes up more space for the tractor. The one in the middle there, that's kind of one that just has a lot, you can put a lot more material in a smaller space. You know, it just depends on your machine. That turner right there is a lot cheaper. We have one like that for a certain application. Or every farmer's got a tractor, so they already have half the equipment. It's their easy input cost to get started. But it really just depends on the application. But you're trying to get, when you get into like an industrial one, you're trying to get that footprint really small because your land is really expensive. So if you got a lot of air, you got a lot of land, really cheap land, you can go with bigger turners and not have that constraint. Okay, so the different type of feedstocks, how we started is we really started with our carbon source. So my family, they kind of started with, incorporating different types of feedstocks for like byproducts of tortillas, bread, we were feeding the cattle. But also it was the wood waste where we ground this up and turned it into cattle bedding. But then it became our feedstock for our compost mix. So it was kind of a blend of both. So we kind of started in this area over here by grinding up green waste and construction wood and making cattle bedding out of it. Then we kind of went into the food waste where it wasn't, we kind of learned the science of when it was okay to use as a feed and then when it needed to go to a compost feedstock. So these are some of the ones we used here. And each tier you go left is a harder feedstock. So on the left there, you kind of see some sludges and biosolids and, cheese waste activated sludge. So the harder material usually has a higher energy content and kind of a better microbial activity. And that is really important to your end use customer for what you're trying to target. So on this is our facility here in Nampa. And what those windrows are really, we started off with them really big because we were thinking bigger's better. But when you start going with these complex materials, that bigger isn't always better. You need more airflow on some of those sludges. So what you do is you have to incorporate more carbon, smaller pile, get more airflow through it, and it actually composts out quicker. So this is our deal right here in Meridian, and we started taking that. So as we kind of transitioned through here, it was kind of an evolution thing. We thought we were going to be out there forever. The city of Meridian decided, hey, we're going to plug a park right in the middle of where you're at and send a pipeline out to us. And we're like, what? You're doing what to us? And then all of a sudden the houses came around us. We're like, oh man, they're everywhere. So we started kind of doing a transitional plan of like, okay, where are we going? What's next? What's our process we're going to do? So, but this was Meridian of what we were originally started with and moved on to. When you do start out, you're very humble in your approach because you want to maintain a low risk. So you use equipment what you have. So you'll start out with like a loader and a small dump truck or something, whatever you have there to make a small entry point for your risk to be low. Then you evolve up into turners and your efficiencies get better the more you get going here on these bigger projects. But don't be afraid to start out with humble stuff of what you have and start out with low risk.
And do you want to come on up? Well,
well, let me take
yeah,
this one. So
you take that.
Yeah, so one of the probably the most key things of a compost facility is having a good carbon source. And a grinder is going to be your key to that. And don't buy them new, buy a used one because they're a very expensive piece of machinery. We did that. You got to be a good welder. You got to repair lots of stuff, but it's worth it. But yeah, these big grinders, they're anywhere from, you can get them down as low as like 500-600 horse all the way up to 2,000 horse. And they grind logs that are probably from me to Caleb and probably as tall as him. I mean, they're massive, massive machines. But go ahead and take Caleb.
Okay.
And Caleb, the microphone's right here, so.
Okay.
Yeah.
So part of the picture we're trying to paint for you, and Mike painted kind of the history, and I want to talk a bit more about our Meridian facility. So again, we have two facilities in the valley here, Meridian and Nampa. And the contrast you're going to see is Meridian is our windrow composting agricultural site. Nampa is our commercial ASP pad. We'll talk more about that site where we handle the hard to handle stuff. So Mike talked about how we got to where we're at, and I want to talk a little about some of the challenges we've had and what's kind of forcing our hand into transitioning over more to Nampa. And so we've showed kind of this rudimentary type of compost that we're doing, windrow composting, and experimenting with the size of the windrows, et cetera, and the kind of simple machinery. So part of the constraints we had, you can see in this photo, is housing started coming closer and closer and closer. So what used to be the family farm out away from town was now becoming next to the city park, literally. And we started getting neighbors who didn't appreciate or understand what we were trying to do. And we coupled that with some operational challenges, and we need some help. And so we had been using Jeff, and we reached out to Jeff again and said, hey, we got to make some modifications to what we're doing to help, in this case, control some odor. So what we worked on, this is a great shot of our turner there, and you can see the windrows and the space we're using is mixing our compost before we put them in the row. So a pre-mix, and then always making sure we have a good moist bio cover, some leaves or some mulch to go on top to filter those organic acids that are coming out, the really odoriferous ones, to help with that. And then we also started waiting 2 weeks before we ever turned it after we capped it the first time, and then routinely churning it once or twice a week after that to keep it highly aerated. So air was key, and the filtration was also key on that to help address that.
Oh, pop quiz. Okay. I showed up on Monday, took all these photos. On the left, we have a 2-foot probe, and on the right, we have a 4-foot probe. Why is the 4-foot probe colder at 120 degrees and the 2-foot probe at 168 degrees? Anybody? Pop quiz? You can read at the bottom. Less oxygen at the core means there's less biological activity. And with less biological activity, less efficiency. And you're also producing methane. And just to prove that point.
James, we've got 3 minutes left.
Oh, you dogs. This is a leaf fall compost. You look over here on this part right there, you'll notice it says 0.9% oxygen, 20% CO2, 8% methane. The next pile over was a wood chip blend, and it had a lot more, 12% oxygen, 4.3% CO2. It takes less space to be more efficient. So we get more material across the pads. Next. Oh, baby. It is not doing it.
You want to jump to the
Yep.
Yeah, you're not going to look.
Mixing with buckets. This is how they proportion, put it into a place, even with the nasty food waste. Next. Do you like these units? Go for it.
Yeah, so we do use some rudimentary stuff there. That loaders are best on the site there. We have a trommel screen. I just want to skip forward because I know we're running low on time here. As you screen that out, let's talk about Nampa. We only got a couple of minutes here.
So you mind if I-
Yeah, go for it.
So basically, they found a site, industrial site, right next to the beet factory. And this is their original site. There's 31 acres just used for composting. The other site that he found was this long, narrow strip. Even though it had a great place to hide behind, we had a problem in that it's long and narrow. And we tried a couple of different ways, like a radial stacker with aerated systems. We tried whole circles that we also provide in Salinas. But we decided on a long strip that we could actually put compost in, move it down towards this end, put it onto a conveyor, onto a stacker, and then let it be curing. And when it's ready for screening, go into the product lines and make all the different products that you see up here in the multicolor. Any overs would go back into the system as biocover, and wood coming in, topsoil here. So when they're making topsoil blends, it's all there. This was 17 acres total. This facility does 520 or 560 tons per day. The one we were just looking at on 7 acres was 200 tons per day. So 2.5 to almost 3 times the volume on half the land. And that's what paying attention process values do. Go for it.
So real quick, this is our pad here in Nampa. You can see the concrete blocks. Basically, think of a football field size pad of concrete, like an aerated hockey pad, air hockey pad, right? It's got air holes in it for aeration. And so we receive our feedstocks on the mixing pad here, place them on the pad. We're cutting our compost time in half. We're handling more product, and we're essentially cooking it better. We're touching it less and achieving those objectives of trying to have a concise compost facility compared to what we were doing in Meridian.
Still using the 12-inch biocover layer,
Right.
and trying to focus on what they want to do is not touch it.
Much more
We're done. We're wrapping.
All right.
That's what the pipes look like. That's what the blower looks like. And that's what the controls look like, to keep it at the right temperature. By keeping it cooler, we go faster as long as it's moist enough.
So it's much more of a sophisticated design because you have a computer controlling your air to control the temperature the entire time, and just instead of letting the ambient temperature and your moisture contents do the work. So it's controlled a lot more.
Piles shrink up and you double them up. This is the pushed up piles for curing. And this is really all it looks like. It's just a pile of crap
That's what we do.
with biocovers. And that is a wrap.
Okay.